Hello everyone, I am Meenakshi Chauhan and in this video I am going to discuss about processor organization. In this video I will be discussing about basics of computer first, that is what is a computer, what are the various components of a computer, what is a processor, then processor organization, and in the last register organization. So what is a computer? A computer is a programmable electronic digital device that accepts data, performs mathematical and logical operations on the data, and provides the results of these operations. Programmable means a computer can be programmed to perform various tasks. Electronic means it consists of electronic components, or we can say it is made of electronic components. Digital means it processes digital data. Digital data means binary data. Binary data means 0 or 1 form of data, where each information is represented by with the help of 0 and 1s. So computer, a device that accepts data from the user, performs some operation on that data, or we can say processes that data and provides the results of data processing to the user. In other words, we can say that a computer has the ability to retrieve, store and process the data. It can take the data from the user, it processes the data, or it can store the data and it provides the results to the user. Now, what are the basic functions of a computer? In general, the basic functions of a computer are data processing, data storage, data movement, and control. Data processing, the main function of a computer is a data processing. In data processing, it processes the data and performs various operations, arithmetic or logic operations on data. Data storage. It can store the data which can be used immediately or can be used in future. Data movement. Computer has various components, so it moves data from one component to another component. So it performs data movement function too. Control. It has many components, so it has some mechanism or it performs a function of controlling those modules or as well as controlling the operation of those modules. According to these functions of a computer, we have various modules or we have various components of a computer. Then components of a computer are, as you can see in this figure, input, output, memory, arithmetic and logic unit, control unit as a part of processor and some interconnection network. So a computer consists of 5 functionally independent main parts. These are input, memory, processor, arithmetic and logic unit, and control unit. Output, interconnection network. Input unit accepts coded information from human operators using devices such as keyboards. Input unit helps a computer to take data from the user. Here coded information means user has their understandable language. It is a symbolic language consisting of alphabet, digits, or you can say some English language, and computer can only understand 0 1 form of language. So input unit should have some mechanism to convert human understandable language into computer understandable language. So some coded information is given by the human or user to the computer, and the information retrieved from the user is stored in the computer's memory. So memory is a component which stores the data or information retrieved by the user. and that information can be used either later or can be processed immediately by the processor. And memory is a medium that stores binary information. Binary information means every information is being represented in 0 or 1 form. Computer understands 0-1 language. So everything which is stored in a memory is in form of 0 or 1s. So every information is stored in a memory. This information can be instructions or data. Instruction, what is an instruction? Instruction is a command which is given to a computer to perform a task. And data is what on which the operations are being performed. Suppose we have A plus B. So here operation is plus and A and B are operands, or we can say data on which addition is being performed. Processing steps are specified by a program. Program is a set of instructions, and what processing is going to be done, it will be always determined by a program. So program is a set of instruction which determines the processing steps. And this program is also stored in memory, as we studied that instructions are stored in memory, or program is a set of instructions. So now what is ALU? ALU is a group of circuits that performs arithmetic and logic operations. Arithmetic operations such as addition, increment, decrement or complement. And logical operations are logical AND, logical OR, logical NOT, logical XOR, etc. So ALU performs operations, or we can say ALU does the actual processing. Finally, the results are sent back to the outside world through the output unit. Once the ALU performed operation and computed the result, that result will be provided to the user with the help of output unit. Same concept will apply here. The result will be in binary form and it will be converted into human understandable language. All of these actions are coordinated by the control unit. Actions of what? Actions of input unit, actions of ALU, actions of memory, all the actions of different modules will be controlled by the control unit. So control unit is a group of circuits that provides timing and signals to all the operations in the computer. It controls the operation of all the modules. And how does it control? It controls by providing timing and control signal to the modules. Control unit controls the data flow in a computer. An interconnection network. So we have multiple modules in a computer. So we should have some mechanism to connect one module to another. So interconnection network provides the means for the functional units to exchange information and coordinate their actions. The interconnection network will connect one module to another, and it also provides the facility of data transfer from one module to another. Now, here start processor organization, which is the important part of a computer. So, CPU, Central Processing Unit. Central Processing Unit is a group of circuits that controls the operation of a computer. It is the main part, or we can say it is the heart of the computer, and it controls all the operation of the computer and performs its data processing function. Data is processed by the processor in a computer, and this CPU is referred to as processor. Now, what are the function of a processor? Processor processes the data. And how does it process the data? It processes the data according to the instruction. So, where does it get instructions from? It get instructions are stored in memory. So, processor will always ask instruction from the memory. So the first function of the processor is fetch instruction. It will fetch the instruction from memory. Next, interpret or decode the instruction. It will find the meaning of instruction to determine what action is described by the instruction to perform. And then it processes the data. It processes the data means it performs the operation determined by the instruction on the data or on the operand. Write the data. After processing the data or after applying some operations on data, it will get some result. So result will be written to the memory or to the output unit. In fetching of instruction, the processor reads an instruction from the memory. Interpret instruction or decode the instruction. The instruction is decoded to determine what action is required and on which data it is required. Process data. The execution of instruction may require performing some arithmetic or logical operation on data. When operations are being performed on data, we can say that instruction is executing. Or in instruction execution, it performs operations on data. Write the data. The results of an execution may require writing data to memory or an input-output module. So this is the internal structure of the CPU. As you can see here that the main parts of a CPU are arithmetic and logic unit, registers, control unit, and internal CPU bus. Here, arithmetic and logic unit consists of some arithmetic and logic unit plus complementer, shifter, status flags. Arithmetic performs arithmetic operations. Boolean logic performs logical operations. Complementer performs some complement operation. Complement in which a bit is complemented. If there is a 0 bit, it will be complemented to 1, or if 1 is there, then it will be complemented to 0. Shifter performs shifting on the bits. It may shift the bits to the right or left. Status flag, these are the registers, or one flag is 1 bit register. And these set of flags tells the status of result, status of recent computed result. Here, a control unit. Control unit controls the operation of all the modules or components present in a computer. Registers. ALU perform processing on the data, and the data must be stored in a processor. So, processor must have some internal storage in the form of registers. So, the main part of processor are arithmetic and logic unit, control unit, and registers. So, these components must be interconnected to coordinate with each other, to transfer the data to each other. So, a processor has some internal CPU bus. So, internal interconnection network is there, or we can refer it to as internal CPU bus. Then components of a processor are ALU, CU control unit, and registers. Internal bus system. ALU, as we have studied earlier, that ALU performs arithmetic and logical operations. In arithmetic, it performs addition, increment, decrement, complement, and logical operations, logical and, logical or, logical not, logical XOR, etc. The control unit. Control unit controls the movement of data and instruction into and out of the processor. It controls the data, movement of the data or instruction in the computer, as well as controls the operation of ALU. ALU does the processing, so it also controls the operation of ALU. A control unit is a group of circuits that provides timing and signals to all the operation in a computer and controls the data flow. As we studied earlier, that control units controls the operation of all the modules by providing timing and control signals. A minimal internal memory consisting of a set of storage locations called registers. So processor processes the data, and data are stored in registers of a processor. An internal processor bus is needed to transfer data between various registers and ALU, because the ALU in fact operates only on data in the internal processor memory. The memory in form of registers. Some mechanism that provides for communication among the control unit, ALU, and register. So interconnection network provides communication between among ALU, control unit, and registers. So far we have studied what is a computer, what are the components of a computer, what is a processor, what are the components of a processor, what are the working of these components of a processor. Now we will study about register organization. This is very important topic because every processor has ALU, CU as a main component, and one processor differs from the another processor only in register organization. So register organization plays a very important role in processor organization, because the number of registers and the type of registers in a processor differ from one processor to another. So we have some categories of registers in a processor. These are user visible register, second control and status register. User visible registers, as name suggests, these registers are visible to programmer, or we can say these registers can be used by the programmer. Here used by machine language or assembly language programmer, because the language of a processor can be a machine language or a assembly language. So always a processor is programmed in either machine language or an assembly language. That's why these registers can be used by the programmer, and these registers will be called as user visible registers. Control and status register. Those registers which are used by the control units, or we can say that the registers which help in the working of a processor, in the operation of a processor, those registers are called control and status registers. So let's start with user visible register. First is general purpose register, data registers, address register, and condition codes. General purpose register, as name suggests, these registers can be assigned to a variety of functions by the programmer. A programmer can use these registers in different purposes. Data register. These registers can be used to hold data only. These cannot hold the address. So these type of register which holds data only, those register are called data register. Address register. Address register may be used as general purpose or they may be devoted to a particular addressing mode. Various address registers are used in various addressing modes. So in addressing mode lecture, you will study different addressing mode used by the processor. Then you will get the idea about what different address registers are used in addressing modes. A final category of register which is at least partially visible to user. User cannot fully use these registers in their program, or they cannot directly access these registers. These registers are called condition codes. Then these registers are always set by the processor hardware. These are the bits register, or we can say status flag. Flag is a 1-bit register. It can either hold 0 or 1. So condition codes are basically status flag, which tells about the status of the result. And status can be, suppose a result is a positive or a negative or a zero or overflow result. Now we have some examples of address registers, and these are segment pointers, index registers, stack pointers. So segment pointers are used in segmented addressing. Here, if different segments are stored in a memory, so the segment register will always tell about the starting point of a segment. So segment register pointer, or we can say segment register, is in a machine with segmented addressing. A segment register holds the address of the base of the segment, or we can say that it segment pointer points to the starting of a segment. There may be multiple registers, for example, one for operating system and one for current process. Then different segments are stored in memory, so different segment register can be used. Index registers. Index register, as you already know about the arrays. Arrays are the index variable, and to implement arrays, we can use index addressing. That's why we can use index registers to implement index variable. So index register are used for indexed addressing and maybe auto index. When you use some arrays and you use increment or decrement, so auto incremented can be there, auto decrement can be there. Then these registers or maybe auto indexed. Stack pointer, as in we studied in stack organization, stack pointer always points to the top element of the stack. So stack pointer, if there is a user visible stack addressing, then there is dedicated register that points to the top of the stack. It always store the address of the topmost element of the stack. When you will study some instruction formats, then you will study some zero address instruction format. Then we need stack to implement zero address instructions, and these instructions can be used in implicit addressing. Implicit addressing means the operands or the data on which the operations are being performed will not be specified explicitly. So in implicit addressing, operands are not given explicitly, they are implicit. Implicit addressing can be implemented by using stack, and stack pointer always points to the top element of the stack. Now control and status registers. Control and status register used by the control unit. So These registers help in the working of a processor. Processor processes the instruction, or we can say processor executes the instruction. So four registers are used for in instruction execution, and these are program counter, instruction register, memory address register, memory buffer register, or memory data register. Program counter. As we studied that processor fetches the instruction from the memory, and which instruction is going to be fetched. So program counter will always tell about the which instruction is needed to be fetched next. So program counter contains the address of an instruction to be fetched. And after fetching the instruction, it keeps that instruction into a register which is called instruction register. So instruction register contains the instruction most recently fetched. Both the register will be used for instruction purpose. Now, memory address register will always hold the address of the data. It always holds the address of the location on which the data will be written or the data will be read from. So, memory address register contains the address of a location in the memory where a word of data to be written or read from. Memory buffer register or memory data register. This register contains the word of data to be written to the memory or the word most recently written. MBR will hold the address and MDR will hold the actual data. Data can be written into the memory, or we are taking the data from memory, then this data will be placed in MDR register. So processor always interacts with memory to fetch the instruction or to fetch the data. So if it is interacting to the memory for instruction, it will use two registers. One is program counter, second is instruction register. If a processor is interacting to the memory for data purpose, it will use two registers. One is memory address register or one is memory data register. Next category of registers is program status word, known as PSW. These registers is also known as status flags. PSW is a register or a set of registers often known as the program status word contain status information. Status information of what? Status information of result. Recent computed results. PSW typically contains condition codes plus other status information. Condition codes as a number is a positive, whether number is a negative, whether a zero result occurred, whether overflow occurred. These are the condition codes, and some other status flag is also there. We will study further. So common flags are: flag is a 1-bit register. Again, flag is a 1-bit register which can either hold 0-bit or 1-bit. So we have some flag registers as sign flag, zero flag, equal flag, overflow flag, and interrupt, enable, disable flag. And in the last, supervisor flag. Sign flag. Sign flag contains the sign bit of the result of the last arithmetic operation. Sign bit denotes the sign of the result. Sign can be positive or negative. So sign bit always tells about the sign of a number, or we can say sign of a result. Sign can be a positive or negative. So we can denote sign flag as a S. It can hold bit 0 or it can hold bit 1. 0 represents a positive result and 1 represents a negative result. Suppose a processor performs 5 minus 3 operation, then result will be 2. Here it is a positive number. So sign flag will be set by the processor to 0, denoting that result is positive. If suppose processor performs 3 minus 5, then the result will be minus 2. The result is negative. So sign flag will be set by processor. It is set to the 1 to denote a negative number. So sign flag can have either 0 bit or 1 bit. A 0 bit denotes a positive number or positive result, and 1 denotes a negative number or negative result. Next flag is zero flag. Zero flag is always denotes the zero result. Zero flag. Zero flag can be set to 0 or can be set to 1. Zero flag, if it is holding 0 value, it denotes non-zero value of the result. If 0 flag is holding bit 1, it denotes that result was 0. Suppose a processor performs 5 minus 3 operation, then result will be 2. It is non-zero value. It is non-zero value. So processor will set a 0 flag to 0 to denote that the result was a non-zero value. Suppose if processor performs 5 minus 5, then result will be 0. So the 0 flag will be set to 1 by the processor to denote that result was 0. So 0 flag denotes whether the produced result is a non-zero value or a 0 value. Next flag is carry flag. Carry flag is set if an operation resulted in a carry in addition operation or a borrow in a subtraction operation. So carry flag will denote whether a carry produced by a addition operation or not. It also denotes in subtraction operation whether a borrow was taken or not. If carry is produced, then carry flag will be set to 1. If carry was not produced, then carry flag will be set to 0. Next, equal. Equal flag is set for equality. When two numbers are compared with each other. Suppose 5 is compared with 5. Both the numbers are equal. So processor will set equal flag to 1. If both the numbers being compared are not equal, then equal flag will be set to 0. Next, overflow. Overflow flag denotes the status that overflow occurred. And what is overflow? Suppose a register of n bit is there to hold the result. Or we can say a register has n bit as capacity. It can hold n bits or it can store n bits. But the result produced is of n plus 1 bit. Then the result of length n plus 1 bit cannot be stored in n bit register. The capacity of register is to hold n bit only. If the result is produced of n plus 1 bit, then we can say that the overflow occurred. Or in other words, in operations performed by the processor, if the here the n bit register can hold a range of numbers. The range can be different for a signed number or unsigned number. When the range of the result is out of the range of the register which can be stored in the register, then we can say that overflow occurred. When overflow occurred in the system, the processor set overflow flag to 1. If overflow not occurred in the system after operation, then processor will set this overflow flag to 0. Next flag is interrupt enable and disable. Interrupt enable disable flag is used to enable or disable interrupts. Now, what is an interrupt? Suppose a processor is doing its work and there is a different device which wants the attention of the processor. So it interrupts to the processor in processor working. It interrupts to the processor to get the attention of the processor. So if interrupt as enable or disable flag is 1, then only this device can interrupt to the processor. So interrupt flag is set to 1, then this device can only interrupt to processor. If the interrupt flag is 0, then this device cannot interrupt to a processor. So interrupt, disable or enable flag is used in interrupt handling to denote that whether a device can interrupt to a processor or not. Interrupt means to interfere in others' working. Next, supervisor mode. Some instruction have some instructions have some rights, and these special right. These instruction can be used in some special modes. And some memory area, which is a privileged memory area, those memory area can only be accessed in some privileged mode. So supervisor mode defines whether the processor is executing in a supervisor mode or a user mode. So in this flag is used to denote whether the processor is executing in supervisor mode or user mode, because certain privileged instructions can be executed only in supervisor mode. Some instruction can be used in user mode, some instructions can be used in supervisor mode, and certain area of memory can be accessed only in supervisor mode. So these all about the flags. Sign flag will always tell about the sign of the result. Zero flag will denote whether the result is a non-zero value or a zero value. Carry will denote that the carry has produced or not in addition of operation, and in subtraction of operation whether the borrow will be taken or not. Equal will denote whether the numbers compared are equal or not. Overflow will denote that the result produced can be stored in result at a register or not. Interrupt enable or disable flag denote whether a device can interrupt to a processor or not. Supervisor mode will denote whether this instruction can be executed or not. For an different instruction require different mode, and different memory location to be accessed require different modes. So as far we studied some what is a computer, what are the function of a computer, what are the components of a computer, and the working of components of a computer. Then we studied processor and components of a processor, then working of a components of a processor. Then we studied something about register organization, in which we discussed about various registers and their purposes in a processor. Now we will look at some important points from the previous discussion. So as we studied that basic operations of a computer or processor are addition, shifting, and complement. So how other operations will be performed in a computer? So the arithmetic operations such as subtractions, multiplication, and division are performed with the help of these basic operations. Subtraction will be converted into addition operation. Multiplication will be performed with the help of addition and shifting operation, and division will also be performed with the help of shifting and addition operations. We will discuss these operations in future lectures. And the number of registers and the type of registers in a processor depend on the design of a processor. So a processor design may differ from the other on the basis of register organization. The content of this PPT was taken by a book written by Sir William Stalling, and second book written by Sir Carl Hammerger. Happy learning. Thank you very much.